Before we talk about encryption, hashing, or certificates, or any related keyword, we need to ask one simple question. Why does cryptography exist at all? Because if we don't understand the problem, all cryptography will feel like random algorithm and buzzwords. Imagine sending a message to someone over the internet. So here, Bob wants to send message to Alice. But this message don't go directly. This message passes through routers, network, servers, and many systems that we do not control. So the real question is not how to send the data, but how to send the data safely. Cryptography exists to solve four fundamental problems in digital communication. Every cryptographic concept you hear, encryption, hashing, digital signatures, exists to solve one or more of these problems: confidentiality, integrity, authentication, and non-repudiation. So let's see one by one what this actually means. First, confidentiality. It means only the intended person can read the data. So here, if you can see in the picture, user A wants to send a message to user B. Bob wants to send to message Alice, "Hi Alice." And Alice can see the same message through the internet, but an attacker, whoever intercept the message, they should see meaningless data. So here you can see this garbage value is there, and that can be seen by this attacker. And for example, your password, bank details, or any private messages should not be readable by anyone in the network. And this is where encryption comes in. Then there is integrity. It answers a different question. It answers, has the data been modified or not? So even if someone cannot read the data or read the message, they might try to change it. So here you can see, Bob wants to send $1,000 to Alice, but an attacker can change this value from $1,000 to $100,000. Right? So cryptography helps us detecting any tampering, even a single bit change, and we will be notified that yeah, there is something has been changed and this we cannot trust on this data. And hashing helps us to do so. Then there comes authentication. What it means? It means who is on the other side. How do you know you are really talking to the bank and not the fake website? Here you can see Bob is thinking he's talking to bank, all the details he is sharing is going to bank, but no, indirectly he's sharing all his details to a fake website which can do anything with this data. And this problem is solved using keys, certificates, and digital signatures. Then there comes non-repudiation. Someone cannot deny an action later. So if a software update was signed by a company and something goes wrong, they cannot say we didn't release this. So if you see in this picture, first this user signed this payment of $1,000, but then it denies. So this cannot be simply done. And this is critical for software updates, legal contracts, and financial systems. And signature helps us to make sure this. Now here's the important part. Each cryptographic tool maps directly to these goals. Encryption maps to confidentiality. Means we can achieve confidentiality with the help of encryption, as we saw. And we can achieve integrity with the help of hashing. And we can achieve authentication and non-repudiation with the help of digital signatures. So you don't have to worry about these encryption, hashing, digital signatures. We are going to cover all of these in the next videos. And once you understand this mapping, cryptography stops being scary. And most of the security attacks are just violations of these goals only. So, if you see any data breach, it means confidentiality has been broken. If you see any malware, then it means integrity has been broken. And if you see phishing, then it means authentication has been broken there. So if you understand cryptography, you understand why behind security. Why? And in the next videos, we'll break down each cryptographic tool one by one, simply, visually, and practically. No heavy math, no unnecessary theory. And this is cryptography decoded. And remember, we keep it simple.